Welcome to lecture 10. In last lecture we have seen the what are the layers of silicon solar cell and what are the anti-reflection coating and how silicon cell are formed, what are the parameters involved in a silicon solar cell and what is the grid in the cell and fingers and bus bar, that and all we have seen in last lecture. Then what are the effect of other parameters like thickness and wafer size, that and all we have seen. So in this lecture how actually manufactured these cells from the silicon crystal to silicon solar cell, what are all the process involved in the industry, that we will see here. Welcome to lecture 10, myself Karthikeyan. So in this lecture we will see about types of silicon solar cell and how silicon solar cell will be manufactured. So first of all, we will see the types of silicon cell. So we know that silicon is used for manufacturing solar cell, right? Yes. In this silicon, there are so many different types that is containing either single crystalline, multi-crystalline, polycrystalline or amorphous. These are the structure, atomic structure and how these silicon atoms are bonded together. According to the chemical bond of silicon, we can get a different type of silicons, that is either single crystal, multi-crystal, polycrystal, etc. See, in this table, you will see first single crystal. That symbol is SCSI, single crystal. What is the grain size? Grain size is the size of the silicon grain that will next converted into the silicon wafer. Okay, I will tell you later what and all grain and how wafer will be formed. Okay, what are the technique used making this one? That is called a float zone technique. Multi-crystalline, symbol is MCSI. The grain size is 1 mm to 10 centimeter. In between that grain size will be there. The technique is like a cast sheet ribbon type of things they are making using this one. These are the type in order to making the wafer. This is the technique. Polycrystalline. Polycrystalline we can get a symbol as a PCSI. What is the grain size of this one? 1 micrometer to 1 mm. So how it will be formed with using which technique? That is called chemical vapor deposition. Then we will go for the next microcrystalline. This is mu C Si. The grain size is less than 1 micrometer. How it will do? This is by plasma deposition technique. So now you will see how silicon solar cell will be formed. See what will happen. This you know that already we have talked about the silicon structure. It containing the 4 electrons at the outermost cell and it is completely bonded together with a covalent bond. The outermost electron is called as a valence electron. This type of atom is combined together make one silicon ingot. After slicing that ingot, you will get this circular shape silicon wafer. This circular shape is called as a wafer. After different technique, we will put some impurities like n-type impurities will be depositing this wafer. Then it will form this solar cell. This is just glimpse. Okay. So most of the silicon cell are made from the silicon wafer. These wafer are like I already told that is either single crystalline or multi-crystalline. So single crystalline silicon is grown like if I combine so much silicon atoms and I want to make silicon cell, that is formed in a cylindrical ingot, and that ingot after slicing we will get circular shape. Then the semi-square structure like polycrystalline, that is in a square shape or rectangular shape. While cutting that one we will get a exact square. Here you can see this is silicon wafer, circular kind of thing. After cutting in top and bottom, we will get the circular edges here. By this one you can see this is the single crystalline silicon. Next we will go for the, this is nothing but the silicon ingot. You can see in this image, this cylindrical image, you can see, this is nothing but ingot. We will call it as a ingot. There are many differently types of ingots that can be made. So after slicing this one, this is made a silicon wafer using that cylindrical shape. This cylindrical shape only we can call it as a Zokalski silicon. So what is the process? If I heat all the silicon with some standard temperature condition, make using laboratory condition in some process by adding some process chemical, we will make this kind of cylindrical ingots. This is called a Zokalski process. Then if I cut this cylindrical shape in horizontally, I will get the circular wafers. Now we will see the multicrystalline silicon. See, previously we seen for making single crystalline, it is from a cylindrical ingots. But for multicrystalline, what will happen? So these ingots are formed in a rectangular shape. So generally multicrystalline is much cheaper than the single crystalline. So we see a lot of multicrystalline silicon solar cell. So after slicing this ingot, you will see the rectangular shape. So you can clearly see that this multicrystalline in rectangular shape, edges are not curved here. Why we have to use multicrystalline? Because this material is bounded little bit lesser than the single crystalline. So grain boundaries whatever contained in the single crystalline, that is little bit lesser than the multicrystalline. So it is little bit efficient than the single crystalline. So what will happen that grain boundaries? That grain boundaries introduced a high localized region of recombination due to the introduction of extra defect energy levels into the band gap. So in this case, what happened? It's generate a more number of electron hole pairs. So that will be induces more number of voltage at the output side. So this is reducing the overall minority carrier lifetime from the material. So as there will be extra energy level of band gap, there will be reducing of the minority carrier. So this will be increases the minority carrier lifetime also. So by this way I will get the some little bit extra amount of energy using multicrystalline silicon. So we will see wafer slicing, how it will happen. Okay, I already told that there will be either square shape ingot or like rectangular shape ingot, another is cylindrical shape ingots. So what will happen? It goes into the process chamber. It is cutted through a laser actually. High frequency laser beam cut in a around 1 micrometer thickness. So you have seen what is the size of that wafer, around 1 mm to less than 10 micrometer. So it will cut that much small size. You can see in this image, see there will be a big chunk of ingot you will get. So this is a germanium ball, actually they are call it as a, so that size is 110 into 180 mm. So what will happen next? It is slides first both the ends first, then remaining that goes to the chamber, then it will make the drill at the center to make the holding. Then what will happen? It will grind at the outer surface and it makes the very clear thin surface, because in this image you can see this outer boundary is not clear, that is a zigzag. What they will do inside the chamber, they will polish the surface and make a very flat layer at the outside. Okay, That while grind, we are generally call it as a surface grinding to make a smooth on the outer side of the ingot. Okay, here we have mentioned what are the that outer diameter thickness that will be 100 mm to like some, if I consider some amount there will be plus or minus zero point 0.1 mm, either more or less. Then after grinding that, one of the surface make a flat in order to hold and removing unwanted things. Then after that sizes will be 32 mm. Then again, see in this final image it will goes to the furnace, and what will happen by using high frequency laser, it will cut or slice these ingots in a smaller wafer, that smaller plate, I can call it as a plate. That plate is called as a wafer, that thickness is 180 micrometer. So after the making of wafer, what will happen, there induces some diffusion of an atom, like impurities they will added that make p and n substrate, they will bonded together. So what will happen, that is called phosphorus diffusion. That is the process of making N substrate on the P substrate. That process is called phosphorus diffusion. Basically that technique is called as a diffusion. You can see in this image what will all happen. There will be a silicon wafer. Then after that, that print check will be attached below that silicon wafer. Then there will be encapsulation will be added. Then little amount of the N type impurities will be adding. Then a metallic paste in order to get a connection, and anti-reflection coating, that and all they will add. So finally they will make one thin layer. Then later what will do, they will print grids and bus bars in the solar cell. Also they will put a silver paste as a bus bar, then they will join, and also they will put anti-reflection coating about the surface of these two, and they will packed together. That is nothing but we can call it as a packing of completely silicon wafer with the n type and other type material, also using some anti-reflection coating. It is laminated together with a small single solar cell. So what and all process involved we will see here. It containing the phosphorus diffusion, then later surface texturing. Then after that texturing process, we will put one coating that is called anti-reflection coating. Then edge isolation, because we have to cover edge also. Then edge is also removed. There will be a graining of the edge will be done. Then later we will attach the bus bars and contacts. Then we will add the substrate later part. Then after that all are sandwiches together, and finally it will laminated and it will produce one single cell. There are actually so many processes involved. Some industry takes some different technique. They are adding some contact previously only. They directly attached P substrate and N substrate together with some junction. Then they will coat some anti-reflection. Then they will do laminating, and that also takes depending on the industries. So this is buried contact. What is that? See, we seen that there will be a fingers in order to carry electron holes pair. So also what we can do, we can add buried contact, because this buried is nothing but that contact is formed inside. Basically this is technique used in the manufacturing of a transistor. There they are using buried contacts in order to give a contact. So what is happening, if we use this buried contact technology, we will get the performance has been much higher than the normally using silicon cell. So what will happen using this period contact, that will overcome the many disadvantages like screen printing or attaching the aluminium contacts. That will also take time, because while sometime what will happen, this is all are done in the parallel process like assembly line. At one side it is slice the wafer, then diffusion will be added, then after that anti-reflection coating will be added, then surface texturing, that and all process will be doing. Then after that later they will add contact also. During that time there may be chances of breaking this wafer. So that's why what they have did, they have used, while making silicon wafer and after putting n type material, they will put this contact also, that is inside both the p and n junction. So that will be increasing the performance. Also there will be less chances of breaking the solar cell. So you can see how contacts are formed. In this image you can see there are so many types of contact can be done. So as I told that some people are contact using silver paste only few these fingers, and from here few fingers, like this they are made. Then finally one aluminium contact will be formed. So these are the different types of contact to the solar cell. So while this contact what and all, this will eliminate the some losses that may be like shading losses, and also it will increasing the efficiency. And by making good type of contact, we are getting the high performance of the solar cell. That and all we can do. After finally what we will get the plus and minus terminal from the each solar cell. Okay, so if we use good type of material or good conductor, we are getting the high electrons and holes pairs. So it is easy to transfer the current in that conductor. In this see you can see how they are make the contact. See if they are using three cells, they are contacted in the top side, or some they are using at the back side of the wafer. And another type is here, see you can, one is at the top, another one is bottom, one is the top, another one is the bottom. And also they are made some rare contact at the bottom side. There are different ways of making the contacts. So this is a texturing, how it will done in the industry. You can see for texturing there will be some different kind of material they have used, like machine they are containing. First what will happen, first they formed a different type of ingots, either cylindrical or rectangular, and they use this ingot in the one chamber. What will do, they containing some texturing material, they put that ingots in this chamber, and it will do the texturing process for entire ingots. This is one of the industry making the texturing process. These are the chamber. Here you can see this is the ingot. Then what will happen, this pipe will be come down, this ingot moving inside, and it will create texturing process. Now we will see the manufacturing process in this video, how actual silicon has been formed in the industry. How solar cell are manufactured in the industry, we can see here basically how much sunlight we are getting from the sun, that we will see how this is 20 trillion watt per hour, you can see that is coming to earth. This is the module. So what and all it containing, see n type, p type, back contact and contact grid. So we will get that small slab, we will see like this sun rays are coming, then electron holes pair will be started, and it will be deposit here and electron flows through this one. So it will glows the my light. Here see you can see p type depletion region and n type, that basic p and n junction. This is the basics. How it will manufacture, that will see. First they will take a substrate. This is the substrate. Then they see like sputtering process, they produce the back contact. Then assembly line, it goes to make wafer. See, it is in wafer there will be a p-type inkjet that is deposited on that one. Then they send to the PTP process, that is called plasma arc lamp process. Here they will make, see, all the silicons are bonded together, p-type or n-type. Then they will flows into the n-type batch. This is also containing n-type material. Then after this thing they are making the process with the grid, like bus bars and other contact were made. You can see there are 1, 2, 3, 4 bus bars and fingers. You can see here what and all. You can see anti-reflection barrier coating, top contact, n-type layer, p-type layer, back contact and substrate. So that, from that one we will get the one single solar cell. Then they are testing in the laboratory condition how its performance and all, like that is called characterization of the solar cell. Then there will be a different way of testing of their efficiency, how a silicon are completely bonded, that and all you can see in this image. So finally what and all process there involved you can see in this video. So it get the high efficiency and lower cost solar cell. So in this lecture you have studied how to make solar cell using ingot. You have also studied the different types of solar cells, that may be multi-crystalline, single crystalline, polycrystalline and amorphous. That and all you have seen. In next lecture what we will see, what and all containing during the module manufacturing. So now you have seen how cell has been manufactured. Now by connecting all the cells in a series, I can get a module in a single method. So how it will form, that you can see. I will put series connection of solar cell that form one single module. Okay, that we will see in next lecture. Thank you.